Okay, we're going to look at some discriminant questions. So the discriminant, remember, is b squared minus 4ac. So when the discriminant is greater than 0, we can say that the roots are real and unequal, or real and distinct. So real being that they exist, and unequal or distinct meaning that we've got two different results. The discriminant is equal to 0, means that the roots are real and equal. If the discriminant is less than 0, that means that the roots are non-real. And there's some visual representations of, first of all, the roots being real and unequal, real and equal, and non-real. If the discriminant is greater than or equal to 0, so that's to say that we don't know if it's greater than or equal, but it's either the discriminant is greater than or equal to 0. Well, all we can say with any confidence at that point is that the roots must be real. So if the discriminant is greater than or equal to 0, the roots are real and unequal. If the discriminant is equal to 0, it's real and equal. But if the discriminant is greater than or equal to 0, the only thing that we can say, because it occurs in both cases, is that the roots are definitely real. Okay, let's do some simple natural fact questions to get going. We're going to state the nature of the roots for x squared plus 8x plus 16 is equal to 0. So we need to first of all identify a, b and c. From viewing the quadratic equation is the general form, ax squared plus bx plus c is equal to 0. So a, as we can see, is equal to 1, b is 8, and c is 16. Okay, so to find the nature of the roots, we find the discriminant, so that will be 8 squared minus 4 times 1 times 16. That's 64, take away 64. So the discriminant is equal to 0, so d equals 0. Therefore, roots are real and equal. Okay, next one. Let's go with 3x squared is equal to 5x minus 1. So first of all, we need to make the thing equal to 0. So 3x squared minus 5x plus 1 is equal to 0. A is equal to 3, b is equal to minus 5, and c is equal to 1. b squared minus 4ac, that will be minus 5 all squared, minus 4 times 3 times 1. That's 25 minus 24, so d is equal to 1. So d is greater than 0, d equals 1. Therefore, roots are real and unequal, or real and distinct. Okay, let's try just one more. So let's go for 4x squared minus 7x is equal to minus 3. So again, let's bring the minus 3 over close, make it plus 3 is equal to 0. A is equal to 4, b is equal to minus 7, and c is equal to 3. State the nature of the roots, so I'm going to use the discriminant. Minus 7 squared minus 4 times 3, that'll be 49 minus, well, 4 4s are 16, times up 3 is 48. So d is equal to 1, so d is greater than 0, d equals 1, therefore roots are real and unequal, or real and distinct. Okay, let's try one more. State the nature of the roots for x squared equals minus 4x plus 5. So let's bring these across. X squared plus 4x minus 5 is equal to 0. A is equal to 1. B is equal to 4. And C is equal to minus 5. State the nature of the roots, find the discriminant. So that'll be 4 squared minus 4 times 1 times minus 5. 4 squared is 16. Minus 4 times 1 is minus 4. Minus 4 times minus 5 is plus 20. 16 plus 20 is 36. So D is equal to 36. 36 is greater than 0. Therefore, roots are real and distinct, or real and unequal. X squared minus 3x plus 4 is equal to 0. A equals 1, B equals minus 3, C equals 4. State the nature of the roots. B squared minus 4ac. Minus 3 all squared minus 4 times 1 times 4. That will be 9 minus 4 times 1 is 4 times 4 is 16. 9 is minus 16 is minus 7. D equals minus 7. Minus 7 is less than 0. Therefore, roots are non-real or unreal. Okay, so let's apply the discriminant to solve some problems. Okay, so for this question, we're going to find the value or values of p such that the roots are equal. Now, if the roots are equal, let's make a statement which is b squared minus 4ac is equal to 0. And that's a communication point to the marker that you know that if the roots are equal, that means that the discriminant is equal to 0. Okay, so we've got x squared minus ax plus p is equal to 0. So a this time is equal to 1, b is minus a, and c is p. So minus a all squared minus 4 times 1 times p is equal to 0. That's 64 minus 4p is equal to 0. So that's 64 is equal to 4p. 4p is 64. P is equal to 64 over 4, and p will be equal to 16. Okay, let's try another one for the roots being equal again. So b squared minus 4ac then will be equal to 0. And we're going to find the value or values of p. So for px squared plus 6x plus 18 is equal to 0. So a is p, b is 6, and c is 18. B squared minus 4ac is equal to 0, being the condition for the roots, the discriminant. So 6 squared minus 4 times p times 18 is equal to 0. That's 36 minus 72p is equal to 0. So 36 is equal to 72p. And p will be equal to 36 over 72, which simplifies down to 1/2. Okay, next one. Again, sticking with the roots being equal, find the value or values for p. So the roots being equal, b squared minus 4ac is equal to 0. And I've got 2x squared plus 2px plus p squared minus 8 is equal to 0. So a, remember, is the coefficient in front of x squared. A is equal to 2. B is the coefficient in front of x. Now be careful, that's not 2. It's the coefficient in front of x, which is the full thing. That's 2p. Now c, a common mistake for c is to say it's minus 8. C is everything else. So mop up everything else in the question that's not in front of x squared or x, and that's c. And that is p squared minus 8. So for b squared minus 4ac is equal to 0, that's 2p all squared minus 4 times a, which is 2, times c, which is p squared minus 8. And that's equal to 0, since the roots are equal. 2p all squared is 4p squared minus 8 bracket p squared minus 8 is equal to 0. That's 4p squared minus 8p squared plus 64 is equal to 0. Okay, so 4p squared minus 8p squared is minus 4p squared. plus 64 is equal to 0. Okay, so I could multiply through by minus 1 there, that will give me 4p squared minus 64 is equal to 0. Take out a common factor of 4, and that's 4 bracket p squared minus 16 is equal to 0. I can then divide both sides by 4, which will give me p squared minus 16 is equal to 0. That's a difference of 2 squares. P plus 4 bracket p minus 4 is equal to 0, and that's p plus 4 is equal to 0, or p minus 4 is equal to 0, which will give me p equals minus 4, or p is equal to plus 4. And that's the final answer. Okay, let's try another one. So this time we've got x squared plus p minus 5 in a bracket x plus 4p is equal to 0. Find the value or values of p for which the roots are equal, therefore the discriminant is equal to 0. So a is equal to 1, b is equal to p minus 5, and c is equal to 4p. Okay, so that's p minus 5 all squared minus 4 times 1 times 4p is equal to 0. So that will be p squared minus 10p plus 25 minus, well, 4 times 1 is 4, so that's minus 4 bracket 4p minus 16p is equal to 0. So minus 4 times 1 is minus 4, minus 4 times 4p is minus 16p. That's p squared minus 26p plus 25 is equal to 0. Two numbers that multiply give 25, add together they give minus 26 is p minus 1 and p minus 25. Since minus 1 times minus 25 is 25 minus 21 minus 1 minus 25 rather is minus 26. So it's p minus 1 is equal to 0, or p minus 25 is equal to 0, and that's p equals 1 or p is equal to 25. Okay, so again, the roots are equal, the discriminant is equal to 0. Find the value or values of p. So let's this time go for x squared equals p bracket 2x minus 5. Okay, so it's just going to be a bit complicated now, but let's get the thing equal to 0. X squared minus p bracket 2x minus 5 is equal to 0. Change side, change sign. Let's open that up. So x squared minus 2px plus 5p is equal to 0. So coefficient in front of x squared is 1, as we can see, a equals 1. Coefficient in front of x is b, and that's minus 2p, and everything else is c, so c is equal to 5p. So that will be minus 2p all squared minus 4 times a, which is 1, times p, which is 5p, is equal to 0. Minus 2p all squared is 4p squared. Minus 4 times 1 times 5p, so that will be minus 20p is equal to 0. You can then take out a common factor of 4p, bracket p minus 5 is equal to 0, so that will give me 4p equals 0, p minus 5 is equal to 0. 4 times what gives me 0, so that's 0, p is equal to 0, or p is equal to 5.